Hi friends, welcome back to LJF. Today we'll see the RH criteria and its application, how to find out the system stability, right? In the last lecture number 19th, we just discussed about the introduction of this, how to find out the roots and how to actually frame the RH table, correct? So today we'll see some more, then we'll come to the problem. So I'll give you the brief summary of the last lecture. So if in the first column of the RH table, the first column there is a no sign change. What it means, your system will be 100% stable system. If any sign change in the first column, it will be 100% unstable system. Okay, and the number of sign changes is nothing but the number of roots in the RHS of the S-plane. Okay, and we know the system will be unstable if we have the number of poles or roots in the RHS of the S-plane. Okay friends, so let's start the problem today. So here in this question, this is the characteristic equation given. If the characteristic equation is not given, you have to form the characteristic equation, then only you can proceed. Okay, so here what is the procedure? I'll make the column of all this and s to the power 0. The order of this equation is 4. Okay, so you'll be having only 4 roots. Okay, they may be in the LHS of the S-plane or they may be in the RHS of S-plane. We'll see. So in the alternating order, we'll write the coefficient of this. Over here it's 1. Then after this you will come to this, it's 3, then 2, correct? Now let's come to this is 2, then this one 1 and then 0. Okay, now let's find the coefficient of this, the third row and first column value. Okay, the first value, and that is, you will multiply this 2 with this 3, you will get 6 minus 1 into 1, this is 1 divided by 2, so you will get over here 5 by 2. Okay, what about this? You will multiply this 2 over here with this 2, 2 into 2, 4 minus 0 divided by 2, so you will get over here 2. Okay, now this is 5 by 2. Now you will find out this value. You will multiply this 5 by 2 with this. So 5 by 2 minus 4 divided by 5 by 2, you will get over here 3 by 5, minus 3 by 5. And this value you will get 2 over here. Now see, this last value, wait a minute. This is the last value. Okay, how it will come? Over here, it will come into just next column, but you have to exclude one row. Okay, over here I'm excluding this row and the next column, that is this column only. Over here it's coming, so this last value is continuously coming like this. Okay, so over here the system is unstable system. The system is unstable system. How many sign changes are there in the first column? Plus, this is plus, this is plus, this is the first sign change. Plus is becoming the minus. So this is the first sign change. Again the sign is changing. It's becoming plus. So you have 2 sign changes. So out of these 4 roots, what you have? You have 2 roots in RHS. And remaining 2 roots will be in LHS. So it will be like in the LHS, in the RHS you will be having 2 roots. Over here also you will be having 2 roots. Okay, this is the S-plane. So in the next problem, or the upcoming problem, we'll see when the poles will lie on the imaginary axis. So is it clear to you? Now we'll see the next question. So let's solve this question. again I have to frame this table. S to the power 4, then 3, 2, 1 and 0. Let me change the color. So over here the coefficient is 1. Coefficient of s to the power 4. Then s to the power 2, that is 2. Then 8 over here. Is it clear to you? Now next is 2 over here. The alternative, this is the 4 and this is 0. This 8 will come over here, then over here. You can write this. Okay, as we discussed earlier. Okay, you have to just pass one row and in the next column you will get the same value. If you calculate this, you will get the same value. Okay, now let's find out this value. 2 into 2 over here, 4 minus 4 divided by 2. Here you are getting 0. So in the first column of the RH table, if you are getting 0, what you will do, you will replace this 0 with the small value. Let's take it, epsilon. You will replace this with epsilon. This is also the small value equivalent to 0. Okay. Okay, I'm writing this epsilon. Now let's find out this value. This value will be 4 into epsilon minus, this is 16 divided by epsilon, isn't it? Is there any problem with this? Epsilon multiply with this 4 epsilon over here minus 16, 2 into 8, this is 16 divided by epsilon. Is it okay? So your first column is complete now. Now we'll see the sign changes we will check over here. Okay, this is the case where we are getting the 0 in the first column. So what is the significance of this 0 we'll discuss, but before that we'll see the sign changes. Okay, so perfectly fine. Over here this is plus, plus, this is also plus. Over here what will be the sign? See, the value is 4 epsilon minus 16 divided by epsilon. So the epsilon is equivalent to 0 or not, means limit epsilon tends to 0. So over here you will get minus 16 divided by, when you will put this value, so you will get 0. So this will be minus infinity, means we are interested in minus, means sign change only. So this term will be always negative. This term will be always negative. And again you are getting the plus sign. How many sign changes are there? So in this column you have 2 sign changes. See, no sign change. The first time we are getting sign change over here, first sign change, then minus becoming plus again. So you have 2 sign changes. What about your system? Your system will be unstable. Okay, your system will be unstable. How many, the RHS roots you have? Exactly 2. 2 roots in RHS of S-plane. Correct. Now what about this 0? What this 0 indicates over here? So this is the point. You have to note down this. If any element in the first column of the RH table is 0, any element, what you have to do is, you have to replace that 0 by epsilon. This is the smallest positive number, and continue the process. Okay, as we did over here. Finally, substitute epsilon equal to 0 and then check the sign changes in the first column. Okay, the process is same, everything is same. The condition is, whenever we'll get the 0 in the first column of the RH table, we'll replace that 0 with the smallest positive number, that is epsilon. Then we'll proceed, and finally in the first column all values will put zeta equal to 0, and then we'll check the sign changes. And then if you are getting sign change, it means the system is unstable. correct? And the number of sign changes is nothing but the number of positive roots. Okay friends, now we'll take the next one. So this is the question given over here. Okay, again I have to form the RH table. S to the power 5, 4, 3, 2, 1 and 0. Okay, so let's start it. 1 over here, the coefficient of this s to the power 5, then the next one is 3, then the next one is 2. Is it okay? Now over here it's 1, okay, then it's 3, then it's 2. Is it okay? So this next row will get 0. Why? Because these two rows are same. So when we will multiply this one with 3, you'll get 3 minus 3 divided by 1, 0, 0 and 0. So this is very special case where we are getting entire row 0. We are getting one row of 0. See over here, this entire row is 0. This is the very special condition over here. Now how to proceed? If we get entire row 0, then we have to make the auxiliary equation. What auxiliary equation means? Over here I'll form the equation s to the power 4. This is s to the power 2 term. Is it okay? And this is s to the power 0 if you remember. This is nothing but my auxiliary equation. I'll write over here auxiliary equation is nothing but plus 2. This is my auxiliary equation. Just above this row of 0 will make the auxiliary equation. This is A for auxiliary equation. Now I'll differentiate this with respect to A's. Over here I'll get 4A's to the power 3 plus 6A's plus 0. Now these two values I'll keep over here. This will be 4 s to the power 3. When we'll differentiate this auxiliary equation, we'll get the order of the equation 1 reduced from the original one. Means the auxiliary equation order is 4 over here, but when you will differentiate it, you will get s to the power 3, means the order of this equation is 3. So coefficient of this is nothing but 4. Over here I'll write 6. So this is the, this is the process how to solve this row of 0 condition. Okay, later we'll discuss what is the mean by this ROZ, why we are getting this. This is ROZ, row of 0. Okay, so now we'll proceed. This is 4 you got over here. Let me change the color. So what is the next? Multiply this 4 in with this 3. 4 into 3, 12 minus 6, 6 divided by 4, it is 3 by 2 over here. And find out this one also. So it will be 2 and 0. Find out this into this. This is no more 0. Okay, this is 6. So 3 by 2 into 6 minus 8 divided by this. Over here you'll get 2 by 3. This is 0. And here you'll get 2. Okay. Now what is the point? The point is, see, this is my first column. Is there any sign change in this first column? No, I don't have any sign change over here. See, plus, plus, this one is also plus, plus, plus. So system is, definitely this is not unstable. The system will be unstable if you will get the sign change in the first column. Over here we are not getting, but I can't say the system is stable or marginally stable. Okay, so we are getting this row of 0. What is this? This implies that ROZ, row of 0, occurs when poles are symmetric about origin. Means this is the condition where we'll get definitely symmetric poles. Okay, there may be symmetric poles over here or over here. The symmetric, this should be symmetric about the origin. This is the condition. Okay, your poles may have over here on the real axis, or they may have on the imaginary axis. Who will decide? For this question, we are not getting any pole over RHS of plane. Okay, for this question, because we are not getting any sign change in the first column, what it means? It means that no poles we have in RHS of the plane. It means there will be no symmetry for this because you don't have any pole over here. So definitely now if you are getting the ROZ, and why we are getting ROZ, it means that definitely there are the symmetric poles about the origin. So your poles will be lie on the imaginary axis. Definitely, for sure, your symmetric poles will be lie on the imaginary axis. They can't be on the real axis. Symmetry means if you have one at this side, so definitely you'll have the another one at the same point in the RHS also. Correct? So for this system, the imaginary, or for this system, the symmetric poles will be lie on the imaginary axis. Okay. So how many poles you have? You have total, five roots you have. So how many are symmetric about the origin? How will decide this? So this will be decided by the order of the auxiliary equation. Okay, see the order of the auxiliary equation. Wait a minute, let me take pen over here. The order of the auxiliary equation will decide the number of symmetric poles. So in the note 2, I can write over here, number of symmetric poles will be equal to the order of auxiliary equation always. So over here we will get 4 symmetric poles about the origin. Okay, so let me frame over here. Wait a minute. So for this we'll have 4 poles which are symmetric about the origin. So they will be over here on the imaginary axis. Over here, these are the 4 poles, and these are symmetric, okay, about the origin. Okay friends, now you may ask why I'm taking individual poles, why I'm not taking this in this way, like 2 will be continuously at this point and 2 will be over here. The repetition of the poles over imaginary axis. No friend, this is not true. Okay, the repetition of the poles will be decided by number of ROZ. If you have 2 ROZ in this, instead of 1 ROZ, you have 2 ROZ. 2 ROZ means you have repetition of poles. Okay, wherever they are, they will be repeating. If we'll get the 2 ROZ, later we'll discuss about this. So for this particular question, if you have 4 poles symmetric about origin and 4 poles are lying on the imaginary axis, so the remaining, the 5th one will be on the LHS. Is it okay to you? So your 5th one will be over here anywhere in the LHS of S plane. No pole will be here. No pole will be here. Why? Because the system is not unstable. If system is unstable, why I'm saying the system is not unstable? Because I'm not getting any sign change over here. Okay. Now the condition is, the third point we'll write over here. So the third point is, if we get entire row is 0, if we are getting entire row in this RH table is 0, then we form the auxiliary equation by using the above the ROZ coefficient. This is the ROZ, row of 0. Just above this, the coefficient of this will make the auxiliary equation. Okay, then we'll differentiate the auxiliary equation and we'll replace the ROZ. This entire ROZ now we'll replace by the coefficient of differentiated auxiliary equation. Okay, see here we form the auxiliary equation. We use the coefficient of just above the ROZ. Okay, we form this. Now we differentiate it. So the coefficient of this, we replaced this entire ROZ by this coefficients 4, 6. Now you are no more with zeros. Now you have 4 and 6. Now we proceed according to the procedure, whatever the rules we have. So we find the the first column of the RH table. Now we checked for the sign change. Over here we do not have any sign change, but it means the system is not stable for sure. Correct? Now what is this ROZ indicate? This is very important point. ROZ indicates the symmetric poles about the origin. Okay, how many poles will be symmetric? It will be decided by the order of auxiliary equation. For this question you have 4 poles symmetric about origin. Okay, perfectly fine. Now no pole for this particular question, no pole will lie on the positive on the RHS of base plane. What it means, your 4 poles will be on the imaginary axis for sure. Okay, and you have 4 poles symmetric. So this is the symmetricity of the poles. Total poles you have 5 for this question, because the order of this equation is 5. So the remaining, the 5th pole will lie over here. I think it's clear now. Okay, now let's come to the next one. So for the same question we have 3 more points. Auxiliary equation consists by even power of S. Why even power? See, this is the auxiliary equation. Okay, here the power of S is even. See, 4, here 2, 0. Why? Because see, the auxiliary equation order is 4. This 4 is showing the symmetric poles about origin. So what do you mean by symmetricity? Symmetricity means you need 2 or 4 or 6. Between 2 people we can have symmetric. Over here one will sit over here, one will sit over here. This is the symmetric. Between 3 or see, wait a minute. So what is my point is, if instead of 4 if you have 5, now can you make it symmetric about origin? You can consider 2 over here, 2 over here, 2 over here. Now what about the remaining one? We can't frame the symmetry by the odd power. So that's why we'll get always the auxiliary equation in the even power of S. So the point is, auxiliary equation consists by even power of S because the roots are symmetric about origin. Symmetric means you need 2 or 4 or 6 or 8. Okay. Now the ROZ occurs, the row of 0 occurs only in odd power of S rows. Definitely your ROZ will always occur in the odd power of S rows. Why? Because just above you will get the even power of S. So if the power is even, you will get the symmetric poles. Perfectly fine. The next one is, the roots of auxiliary equation is nothing but the closed loop poles. Here are the roots. See, this is the auxiliary equation. The roots of this equation will be your the closed loop poles. Okay friends, so these are the 5 points related to this question. Okay, so let me take another one. So this is the question given. So I'm leaving this question for you. This is the homework. Please try. In the next lecture I'll solve this. Okay, so for this class it's enough, I think. In next lecture we'll discuss about the RH concept only. Okay friends, so for new updates you can subscribe LGF. You can find us on the Facebook for the doubt solving. We'll meet in the next class. Till then, take care and bye.